In this video, we are going to see about the design and implementation of half adder as well as full adder circuit. So let me see the design or the logic diagram of the half adder. So this is the half adder circuits. So where we have two inputs and two components are like XOR gate as well as AND gate with the two sets of input terminal, and we are going to measure the output of XOR gate as a sum and the output of XOR gate as a AND gate as a carry. So XOR gate is nothing but the truth table operations are like if any one of the input terminal is high, the output is going to be high. Whereas the AND gate is nothing but a multiplication operation. If any one of the input is 0, the output is 0. When both the inputs are 1, the output is 1. Okay. So with this logic, we are going to give this logic diagram in the Logisim software. So first we need an XOR gates. So we just click onto that XOR gate. So in the cursor now we are going to have the XOR gate symbol. Place it in the workspace. And here we have like around the number of inputs to be around 5. But as per our logic diagram, we are going to use only two set of inputs. So to reduce the number of inputs, you can see here in this selection XOR gate in the fourth option like number of inputs. So just click onto that and you can select how many number of inputs are required. So now I change the 5 number of inputs to 2 number of inputs. Now I'm going to get the AND gates. So AND gate been placed in the workspace. Here also I have around 5 inputs. So just click onto the number of inputs and reduce to number of inputs as a 5. So now we need 2 inputs. So for the 2 inputs, place the inputs of ones and zeros. And I need an output. So one output is placed at the XOR gate, which is going to give the sum. And the second output is placed at the output of AND gate, which is going to give the carry. So now we place the XOR gate, AND gates, 2 set of inputs and 2 set of outputs. Now we are going to connect all these things with each other. So if you place the cursor near the terminal, a green color dot has been enabled, a circle has been enabled, which means that the wire has been, we're going to start. So just click onto the respective input terminal and drag it to the input component. Similarly, I kept the cursor in the input terminal of an XOR gate. Just drag it and continue to the input terminal. Similarly, I'm going to connect the AND gates to the first input and the second input of AND gate to the second input. So the output of XOR gate is connected to one of the output terminal, and similarly the output of AND gate is connected to the other output terminal. So let me give some name for these two inputs, as we mentioned that A and B as per the logic diagram. We'll mention here A as well as B. So now we mentioned the two input terminal now. Now we need to change the inputs now. Now what is our first input pair? If the input is 0 and 0, the carry is also 0 as well as the sum is also 0 because there is no input. All the inputs are 0, so both the carry and the sum outputs are 0. So if you see our logic, the output values are 0 and 0. And if I'm going to give any one of the input as a high states, so for changing the values, just press this hand like a symbol which changes our input value now. So I'm going to change the input A value as 1 now. So as per the logic of XOR gate, if any one of the input is high, my output is high. Whereas for the AND gates, if any one of the input is 0, the output is 0 now. So now we have a sum as an output. Now if I change the A value to be 0 and the B value to be 1. So again this is also for the XOR gate, like if for XOR gate, if any one of the input is high, the output is high. And for the AND gate, if any one of the input is 0, the output is 0. When I make both the inputs as a high states, 1 and 1. So in this cases, the AND gate output will be high and your XOR gate output will be low, which means that there is a carry value and there is no sum values. Now let me see our truth table. So for 1 and 1, there is a carry, but there is no sum. Okay, so now we verified our truth table for half adder. So by the same way, we are going to give for the full adder circuit also. Let me go to the logic diagram of a full adder. So full adder circuit is nothing but the combination of two half adder. Okay, so here we're going to have this as one half adder and this is a second half adder. Both the half adder are connected with one OR gates. So we'll continue with the same. So we can select this first. I'll make this as 0. So let me select the component. So I'm selected all the components. Let me take as a Control C and Control V. So I placed all the components. Okay, so it is all equal now. Now let me see what are the changes. So let it be the first half adder be as such, but the second half adder we are going to do some modification. So for the second half adder, we are going to give one of the input terminal from the output of the first XOR gate, and the second input of the XOR gate is taken from the third input of C. So let me change that now. So we will remove all this input terminal from here because we're going to give a common input only, and also we'll remove this character, and we will remove this respective output terminal also. Okay, now we'll connect the output of XOR gate to the one of the input of the second XOR gate, and we are going to use the third set of input. So this third set of input is given to the second input terminal of the XOR gates. Okay, yes, so now we have given the output of first half adder XOR gate to the input of second half adder XOR gate, and the second terminal of the XOR gate is given to the third input of C. Now for the AND gate, the output of XOR gate, that is the first half adder XOR gate, is given as an input terminal, and the second input of the AND gate is going to be the third input value. So the output of XOR gate is given as an input. So now we need to remove this wire. So let me remove this. Okay, so output of XOR gate is given as an input to AND gate, and this is given to the third input. So now we have given the AND gates. Now these two outputs, the outputs of two AND gate are given to XOR gate. So I'm going to add one XOR gate now. I added the XOR gate, and again it is with the number of inputs as a 5. Let me change that to 2 set of inputs, and one set of input is nothing but second half adder connection output, and the other input is nothing but from the half adder of the first half circuit, which is taken from the AND gate. Okay, now this output of OR gate is given to the output bulb. Okay, right. So now this is going to be my third input, so I'll give the name as C, and this output is nothing but sum, and this output is nothing but carry. Okay, so now we have created, or we designed a full adder circuit using two half adder circuit. Okay, so which means that I have used 3 set of inputs. For half adder circuit, I've used only 2 set of inputs. Okay, Now let me verify our truth table. So if I give the inputs as 0, 0, 0 means the sum and carry value as 0. So that is what now the present state. Alright. Now if I give the input like all the inputs as 1, so the carry and the sum value are 1. Let me verify that. So I'll touch this hand symbol for all them to make my to change my values. So 1, 1 as well as 1. So both my sum and carry are 1. So if I make the combination as 1, 0, 1, which means that sum is 0, carry is 1. Let me verify the truth table. 1, 0, 1 means carry is 1 and the sum value is 0. Yes, so carry is 1 and the sum value is 0. So here we verify the truth table for full adder circuit. Thank you.